Welcome to our viewers. Thanks for joining us for our Petabytes and Popcorn, Protect Your Data During Uncertain Times with Pure Storage and Cloudian. So joining us today we have Rob Schoem, who is a flash-based systems engineer at Pure Storage, and David Glow, a senior systems engineer manager in the central region for Cloudian. Welcome, Rob and David. With that, I'll hand it over to Rob.
I'm Rob Schoem. I'm a data architect with Pure Storage. And today I'm going to be talking about FlashBlade and Pure in general. But instead of kind of talking about what FlashBlade is and kind of going into technical details, I'm going to talk more about why FlashBlade is and the reason that Pure developed FlashBlade for ourselves, actually. If anybody's not familiar with Pure Storage, been around for quite a while now. FlashBlade is actually the second product that Pure has come out with, FlashArray being the product probably everybody's most familiar with. But at its core, Pure we tried to build ourselves as a different storage company. The first part of that being making, instead of the, every 3 to 5 year lift and shift, forklift upgrade of your environment, doing more of a subscription model and having upgrades be minor events where you get to leave your storage and all your data in place. The second part of what Pure really was driving towards as kind of a part of our full, kind of change in what storage should be to customers is a commitment to the customer, actually. So we have an NPS score of 83.7. Even things like AppleCare have in the 40s. So, we try and be the company that customers want, and I'll kind of show you how we use data to really drive that customer experience and make Pure a different company. And the last part of this, as far as kind of these 3 pillars here, is the actual technology. So Pure Storage has been the up and to the right. Gartner doesn't like it when we say the best, but we are the highest on ability to execute and completeness of vision for 4 years in a row. They actually Gartner changed their measurements for all flash this last year, so a little bit of a shakeup, but we're still all the way up and to the right there. And this all kind of comes together with the culture at Pure. So what you'll find with Pure's employees is a passionate group of people that want to deliver, this NPS score of, 83.7 and this kind of amazing customer experience. What I'm going to talk specifically today about is FlashBlade and kind of where FlashBlade plays in potentially your environment and where it really plays in Pure's environment. And I'm going to use this kind of new data analytics, data pipeline to explain kind of where Pure has come from and where we're going with our own data. And I'm hoping that this story really lines up with where everybody on the call is, or at least you're at some point on this journey with us. As I'm sure everybody knows, when you get into analytics and you get into big data, it is an alphabet soup of all of the different tools and technologies that are out and available, and those are changing every day. Things like Spark and TensorFlow were unheard of just a couple years ago, and now people are talking about dedicating clusters to things like Spark and streaming analytics and stuff like that. And what I'm really going to build towards here is kind of Pure's current model for our own analytics, for the analytics that we're running for our customers. And I'll show you kind of where we give data back to the customers and allow them to use this data, as well as where we use the data to provide a better solution for the customers. So I'm going to start with, this is 1.0 of Pure's venture into analytics here. So this is an internal use only tool. As you can see, only our support organization has access to this. And we built it all in the cloud. It was the easiest way to get started. We thought, this will be fast, it'll be easy. Support will be able to see all the telemetry data from everybody's environment, for all the flash arrays that are out in the field. And we'll be able to use this data similar to how another storage company would use it. We get the logs, we scan through the logs, make sure that there's no failed hard drives and controllers that are going bad or network connections that are not configured correctly, and we'd reach out to the customer. The problem with this is it's all reactive. This is all just what we see when it comes in. When it really started to change is when we hired our first data scientist. We hired a legitimate data engineer, and he said, that's cool, you guys are doing this stuff, but you really got to start tagging this data. You really have to start formalizing this data pipeline so that you can use the data for more than just reacting to what's going on in your environment right now. So with this model here, we're still out in the cloud. Support is still the only one with access. And then all of a sudden, a new team gets access to the data. So the second team is our escalations team. They've hired their own data scientists, and what their goal is now is, what can we do to start predicting things for our customers? So instead of telling you, hey, your hard drive failed last night, we can say, based on read misses and a bunch of other different things, that we think that NAND is about to go out, or we think that SAS drive is about to go out. What if we can proactively reach out to you and open a case and have a drive sent to you before it even fails? That's much better for you. You don't have to worry about your data being at risk, and it's much better for us because people aren't calling in and saying, hey, my drive failed, can you send me a new one? So we get this second team in here, and they start using the data too. That's super successful. So what happens, like at any other company, everybody wants access to this data. So we have multiple teams in here messing with the data. And that starts to cause problems. So as you can see, our growth is really, the amount of data we're starting to store is kicking up here as we grow out. And we end up with this big data warehouse so that lots of people can access it, and we can start doing more intelligent things with the data. This is where, this is 2016, and this is about where we're going to start releasing this data back to the customer through the Pure One interface. So right now we're just, it's still called Meta. It's not really an official product, but we're starting to see the value in the data for ourselves, and we think there's value in the data for customers too. We think that you guys can actually use this data. The next kind of big step here is we increase our product portfolio. So now we're starting to collect VM analytics. We added the FlashBlade product around 2016. And so naturally, what's happened is data has blown up on us. Everybody wants to use the data, and anybody that's gone into the cloud understands that it's easy to get up there. It's easy to put your data there. What gets really, really expensive is running all those I/O operations when you're trying to do analytics. You're trying to do some machine learning and some deep learning on the data that you already have access to. So what does that buy us? That buys us an AWS bill that is over half S3. All of those IOPS are killing us. So we realize at this point it's time to do something different. And I'm sure there's lots of people out there that are kind of getting to this point where data science was a fun project. It was maybe even a skunkworks operation. You've just got your first data science team. But the company has realized that this data you've been collecting is valuable, and it can make a difference and make you can have a better product because of this data. So we had to go back to the drawing board and figure out how do we get this, how do we make this solution work? So our first run at this was potentially just do everything on-prem. So if we can slot this FlashBlade product in here, and we can kind of change some of the tools we're using by switching to Kafka and Kubernetes, that makes us a lot more flexible instead of using Amazon's Redshift and S3. I'm sorry, not S3, EC2. And so we get this, we're starting to be able to control our data is really what it comes down to, and be able to use it. But the goal still was we want all of the data in one place. So we didn't want to have to start building out our Kafka or our Kubernetes cluster and then have a separate Cassandra deployment and then have MongoDB running somewhere else. We really wanted this data all to be accessible in one spot. And that's where FlashBlade really came in. So here, in this between 2016 and 2019 is where FlashBlade has matured itself enough that we're using it for our own internal and external use cases. So what we've really come down to now is this model where for us, the next logical step for us was to do a cloud adjacent. So we happen to use Equinix, any carrier neutral facility next to a hyperscaler will allow you to put this high performance storage in there and cut that half of your S3 bill out right away. This model also has allowed us to introduce some serious machine learning. So under the hood, we now have on-prem or in our colo facility, we have DGX-1s. And these DGX-1s now allow us to do legitimate machine learning without having to worry about the exorbitant cost to run machine learning and those types of functionality out in the cloud. So to get this, we really had to design FlashBlade to do something completely different. In the realm of storage that you see for kind of these streaming analytics, big data, machine learning, you tended to have everything be siloed. So, we built FlashBlade for this AI cluster where, it's unstructured data, everything's being run real time. You don't know whether it's going to be sequential or random I/O. You don't know if it's going to be lots of small files or big files. So we need to be able to handle everything. The nice thing about that, building something for that specific workload, is it has lended itself really well to these other workloads that can run simultaneously on the box. So, for rapid restore, customers that have critical databases or critical infrastructure that has to come back in a minimum amount of time to make the company function again, FlashBlade becomes a good target for that. And then the traditional data lake and streaming analytics that, you'll notice have some similarities to this AI workload really lend themselves well to a high performance, NFS S3 solution. And then on top of just that performance, it's the completeness of our vision for you. So doing things like safe mode snapshots, FlashBlade has integrated into it snapshots that are hidden away and protect you against ransomware. So we have things, there's functionalities built in where at least 2 administrators have to call into support and provide a PIN number to make any changes or enable or delete any of those snapshots. So that, if you're doing backup or you're putting your critical IoT business data on here, you don't have to worry about ransomware coming through and ransacking your environment. We have these tools built in that actually Dave's going to talk a little more about how we integrate for protecting your data up next. So walking all through this, you can kind of see where Pure has come from and where we really wanted to end up for our analytics. And hopefully that's been helpful to you to kind of see, what a company has done for analytics and how we've matured and made mistakes and changed over time to have something that, is a big differentiator for our company and can hopefully be a big differentiator for your company too.
So I am David Glow. I am a systems engineer based out of Chicago, and I want to do a brief introduction to Cloudian, tell you a little bit about our company, and then at the end I think we're going to tie it all up with how Cloudian and Pure can be very complementary in a variety of environments. Let's start off, first of all, who's Cloudian? Cloudian is the leader for on-prem S3 object storage. I'm sure most of you, if not all of you, have heard of Amazon S3 and you associate it with public cloud. But when we talk about S3 compliant storage, we're really talking more about compliance with the API calls that Amazon S3 makes available. So in other words, think of Cloudian as being Amazon-like on-prem within your own data center, right? There's a variety of reasons why data may not be able to be stored in public cloud. It might be regulatory. There are for a variety of reasons, right? So we fill in that gap where we are considered the first step into cloud. So in other words, you can deploy Cloudian on-prem, but we also have the ability to tier out to public cloud. So if companies are thinking about going to public cloud, but they're hesitant because Once again, it might be compliance reasons, things like that. You could start off with Cloudian. You could start off small, and then you could grow to literally exabytes in size. It's a scale-out architecture, meaning that appliances that not only have CPU, cache, and GigE ports, but additional capacity, right? So every time you add an appliance or a node, you're not only increasing capacity, but you're increasing performance. Over time, it's a pay-as-you-grow model, but over time, not only does the cluster get more efficient from an overall utilization perspective, but it also gets more efficient from a performance perspective because you continue to add additional compute. So just kind of want to, at a high level, give you an idea of like where object storage in general fits in, right? As you can see there on the left, you have your fast data. Pure does that probably better than anybody else. And that's, that 20% of that data, that transactional data. There's a variety of reasons why you may want something to go very fast. FlashBlade in particular is what I like to consider, fast object storage, right? Where you might want to do a restore to FlashBlade or an archive to FlashBlade so that you can get a very, very fast restore time. We're going after that other 80%, the deep archive, right? And you can see the use cases on the right there where, a lot of that 80% of that data is being generated. Both Cloudian and Pure both play in that 80% place, or actually if you look at it, it's an entire 100%. We can be very complementary in a variety of workflows, including data protection, which is probably the lowest hanging fruit that we have today. Storage as a service, so we do very well in the ISP space. Archiving, right, for big data, media and entertainment. So there's a variety of workflows where object storage is being put in place. And then once again, I'd just like to kind of just imagine Amazon S3, but typically at a third of the cost on-prem where you're managing it, you're owning it, you operate the appliances. So let's talk a little bit about Cloudian and how it can be distributed, right? So much like AWS S3, we have the ability to be deployed across multiple data centers, multiple regions, right? Cassandra is the underlying technology that allows us to be geo-distributed. So you could start off with as little as 3 nodes or 3 appliances in a single data center. You can grow that out into a multi-data center distribution. And then you can actually also then grow into multiple regions, just as AWS does. You have the ability at the bucket level to determine where that data is going to live, meaning you might create a RF3 or replication policy of 3 and have 1 copy stored in 3 different regions. You might have 2 different data centers in 2 different countries, and for regulatory reasons, some of that data is sensitive and is not allowed to leave that's a specific country. You can create a bucket where the data is only replicated to the data centers within that specific country you want to maintain the data in. So once again, as I mentioned, very much so like AWS S3, we have Cassandra, which same underlying technology that Netflix uses. I always like to use Netflix as an example because you pretty much scroll through, you order a movie, and it just gets served up, right? You have no idea whether it's coming from a data center in Atlanta or a data center in Florida. You just get the data served up. Think of object storage in that exact same way. You have the ability to assign a data protection to your objects. You determine where they want to live. And then from an end user perspective, it doesn't really matter what happens. You request an object and it gets served up. In addition to being, geo-distributed, we have exabyte scalability, right? And when I say exabyte, I mean exabytes. So you have the ability to scale in very, very small quantities, as little as 96 terabytes per appliance, all the way up to 980, actually 1.5 petabytes in a single 4U unit. I'll talk about our appliances in a few more slides, but what I'm trying to say is we have the ability to service you from a very small perspective, and then we also have the ability to allow you to scale in gigantic chunks. Object storage, I think if you remember looking at Rob's slide there, where he showed that little pie chart. I believe S3 was the one in red that was, 51% of customer costs, right? It's no secret that S3, went from, 0 to $20 billion in just a little bit over 10 years because of the massive explosion of data. Nobody's thrown anything away. People need to archive it because maybe they're going to run analytics against it. Maybe they're going to do something else with it. But that's where we fit in, right? We fit in that the need to be able to be a huge, large repository for archive data. In addition to being able to scale, we also have cloud integration, meaning that we have the ability to provide a hybrid solution where Cloudian can be deployed on-prem, and then you can set up policies to tier to your major cloud providers, meaning AWS, GCP, as well as Azure. So real quick overview, right? Cloudian is an object store. We don't do any type of block storage or anything like that. But we do have two main products, right? Our flagship product is HyperStore. That's our object store. That's what I was comparing very much to S3-like. And some of the key features of that is that we like to say we are S3 compatible or 100% S3 compliant, meaning that we adhere to the S3 APIs better than anybody else out there in the business. Why is that important? Because as S3 releases new S3 API calls, you might have a specific software application that wants to take advantage of that new functionality. And if you're not adhering to the S3 API calls from day one, you might have to wait 6, 9, 12 months before your object storage vendor picks up that API call and supports it. So very, very important. Scale-out architecture. So, I'd like to say that a lot of times if you look at other architectures, there's a lot of moving parts and pieces. There's sometimes a metadata controller. Sometimes you'll hear the term admin node, which are really single points of failure. This is a true scale-out architecture that allows you to have no single points of failure. All nodes are peers to each other. And based on your data protection scheme, you could lose anywhere from 1 up to 4 nodes, or even an entire data center, and still have 100% availability to your data. So it's built for 3 main reasons, right? 1 is to be S3 compatible, 2 is to be highly scalable, and then thirdly is to be highly available. We also have another product called HyperFile, and what it really is it's a file gateway, meaning you could deploy it on an appliance or virtually, and it allows you to present out NFS and SMB services to clients. What happens in that workflow is that a client would connect to an NFS or SMB share. As soon as that file is closed, a HyperFile gateway itself, which is configured with a certain amount of cache based on your workflow, would then index that file. We have a database running to index it, and then store a primary copy on HyperStore as an object. So in other words, you consider your workflow. You configure the cache on HyperFile to support a small number of it, and then the backend HyperStore would support or be the main repository for all your files. There's other products out there on the market today that also do this in a similar fashion. I'd say one of our key differentiators is that we are bimodal. What that means is that once you write a file through HyperFile and it's stored as an S3 object, you can then have any S3 application read that NFS or SMB data in an S3 format. So other products out there today, if you write data through a gateway, you have to go through that gateway because that gateway is the owner of the bucket. And the only way that file can be accessed is through that gateway. With us, we are truly bimodal. In addition to that, we have some of the standard features that you'd expect for a network-attached storage device, although this is more of a gateway. We support Windows or NFS. We do have Worm, and then Active Directory integration as well. Scalability. So, once again, I'd like to just say that we start smaller than anybody in the industry. 3 nodes, 96 terabytes usable, and then from there, the sky's the limit. You could grow to petabytes, exabytes, and what's nice is that allows you to pay as you grow, right? So if you know that you need 1 petabyte today and in 5 years you're going to be at 10 petabytes, you could just continue to add appliances as needed. You don't have to buy that whole 5 petabytes up front. So once again, it allows you to pay as you grow. From a cloud-ready perspective, we give you the ultimate flexibility when it comes to storing your object data, right? So private cloud, or otherwise referred to as on-prem, that's what we've been talking about primarily. This is where you would deploy our appliances in a single DC, or on the example on the left, happens to be a multi-DC environment where you have hyperstore appliances deployed in 2 different data centers. You have a replication policy where you're replicating data between them. That is your first realm, or first entry into the cloud. And then we support what you call hybrid cloud, right? Hybrid cloud is where you still have an on-prem private cloud deployment, but you set up policies that say after 30 days, move this data to S3, or move this data to GCP, or move this data to Azure. What's unique about Azure is that, they don't support S3. So when we tier to Azure, we actually are acting as a gateway, taking S3 data and converting it into native Azure blob format. We have a variety of customers. Some do that. The reason is that they may be receiving data in S3 format, or they have strong relationships with Microsoft, and there might be some tools within Microsoft that they want to use to analyze that data. Obviously, you can't send S3 data directly to Microsoft Azure, so we can act as a gateway to actually move S3 data into Azure Public Cloud. And then once again, we maintain the metadata, so we understand exactly where that data is being stored, so that if a client wants to recall it, you could set the policy as to how that data will be restored, whether it's just streamed directly to the end user without interruption, or whether you get redirected to public cloud. But once again, so we do have tiering to the cloud. And then the third option, which is somewhat unique to the industry, is we like to say we're also multi-cloud, meaning that you don't have to be have a relationship with any one public vendor. You can deploy an instance of Hyperstore, and you could have some buckets tiering data off to Azure. You could have another bucket tiering data off to AWS S3. You could have other buckets deploying to GCP, right? So this is where it kind of gets interesting, especially the service provider industry, right? Whether you're a large corporation acting as a service provider to various departments, or whether you're a service provider, true service provider providing services to different customers. This allows you to basically give them the availability or the right to tier data to any one of the 3 public clouds. Another one of our differentiators I like to talk about is ease of use, right? We have both a GUI interface that is just drop dead easy to use when configuring both Hyperfile and Hyperstore. We also can be fully customizable and fully scriptable from an API perspective. So in other words, if you wanted to put in automation where you don't want to have somebody go into a GUI every time a new user gets added to your company, you could do scripting and automation that would allow you to automatically generate users, set priorities for them, be able to give them access to certain buckets and replication policies. So once again, ultimate ease of use, as well as you can go as deep as you like from a programming, scripting, API perspective. Real quick, I'm not going to spend a lot of time on our appliances, but we do have 3 different offerings. Starting at the left, you have the HSA 1500. That's a 1U platform with 12 drives, and you can see the size of the drives determine the density of each node, anywhere from 96 terabytes raw up to 168 terabytes raw. In the middle is the HSA 4000. This is actually a 4U chassis with 2 nodes in there, so we dedicate 35 drives to each node, and the sizes of the drives determine the density on this node as well, right? From 560 terabytes raw up to 960 terabytes raw. And then on the far right is one of our newest products. It's a joint relationship we have with Seagate, and it's called HyperStore Extreme. This too happens to be a 4U platform with 2 nodes in the chassis. But we have 96 of their 16 terabyte drives. So 16 terabyte drives are relatively new to the market. I believe, unless something's changed, we are the only ones to date that are offering Seagate 16 terabyte drives to the general market. And you can see here that is 1.5 petabytes raw. So typically some common questions we'll ask you when you're looking at deploying something is how much capacity do you need today? How much do you think you'll be at in a year from now, and maybe in 2 years from now? And based on the requirements, if you say I'm going to be at a petabyte or less, we might be looking at that 1,500. If you say I need 2 petabytes, we probably look at the 4,000. Reason being is it's going to be more cost effective because it's going to take less hardware, less usable hardware to get you to that usable number. And then anytime you're talking about 5 petabytes or more, which is when we'd be looking at the HyperStore Extreme. I know we're throwing out some big numbers here. I don't know what type of audience we have where you're going, geez, petabytes, exabytes, but I remember when I started in this business and I sold a 2 terabyte array to somebody, and they're like, 2 terabytes, I couldn't possibly, need anything more than 2 terabytes for the next 2 years. And now here we are with 16 terabyte drives. So believe it or not, a lot of people aren't throwing away data, and the requests for multi-petabyte configurations are, quite common. And, that's why we have a wide range of offerings. But the key message here is that you don't have to be a multi-petabyte customer to be interested in Cloudian. You can start off with as little as 96 terabytes usable and grow into any one of these configurations. So S3, right? So as I mentioned before, when we talk about S3, we talk about the S3 API, not necessarily the public storage offering that S3 has. But if you look on the left there's a variety of companies and products that all have what they say is an S3 connector, right? Which means it allows you to move data to public cloud. You could just think of any application that says they can move data or they support S3. Think of S3 as being synonymous with Cloudian. So once again, I mentioned before that we are 100% compliant with the S3 APIs. And that's a real big deal because, once again, you want to be able to take advantage of new features as companies release them. We do a lot in the backup space, as does Pure. And before I get to that, though, actually, let me talk a little bit about this. So the latest S3 feature that was released for the S3 API is Object Lock. And Object Lock is really, think of it as like worm for object, right? It's compliance. So in other words, you have the ability to deploy it in one of 2 ways. You could deploy it in a way where somebody cannot accidentally delete a bucket, but an administrator can go in and, unlock that bucket and delete it. And then there's a governance mode where you could actually, a compliance mode where you can actually put in a retention period of 5 years, and nobody, not even an administrator can get in there and unlock it, right? So we are 17A4 compliant. We are the first object on-store object vendor to support this, and you'll start seeing more and more software applications go out to support this. And I mention this because once again, we are 100% compliant. This is a big feature that a lot of vendors have been waiting for. Specifically, Veeam is the first one that has come out with Object Lock. So what that means is now you could have a workflow, as you can see here, that includes Pure, actually the Pure family, right? You have FlashBlade, you'll have FlashArray, but Veeam can back up data to Cloudian in an object-locked bucket, which means it's going to be completely immutable. When you're talking about ransomware, which is a very hot topic, not only do we have the ability to store data in a worm-locked bucket where data cannot be accidentally deleted, we also have other features within our software stack that we didn't talk about, such as secure shell that actually removes the root access away for our HyperStore appliances so that administrators can still manage the cluster, but they can't go back, reverse the time clock, or do anything to get around the compliance that had been put on that bucket. So even if you had a rogue employee, forget about ransomware, right? Somebody, you got a ransomware. What about if you got a rogue employee that wants to do some damage before they leave? This solution that you're looking at here protects you from ransomware as well as rogue employees. Maybe, Rob, you'd like to jump in at this point and kind of talk a little bit about Pure FlashBlade and what it has to offer within the ransomware workflow?
Yeah, absolutely. I kind of touched on it briefly. I'm going to move forward one here. So the ransomware portion of this is those immutable snapshots. So the ability to have the administration team, the infrastructure team call Pure support and say, we want to enable protected snapshots or immutable snapshots. And what happens there is support will enable a snapshot policy based on whatever you would like. And then those snapshots, that snapshot policy is then hidden away from even the administrative teams. So if ransomware were to hit your network, as it gets smarter, as it starts looking for backup policy retention times and those kind of things, being able to take your infrastructure and bring it back to a point in time is critical. It's actually a feature we added in for a large social network that had a requirement for ransomware, and we've enabled that for all customers now instead of just having it run in the background. And where that really fits in here is kind of your bigger backup environment. So Cloudian and Pure work with a lot of different backup vendors, and these are just some examples here where you can see you can use your backup, the same backup solution, and just by creating policies, you can more intelligently land your backup data where it needs to be. So a lot of customers will use FlashBlade for critical infrastructure, and ERP system and IoT system that you can't afford to lose that data, or you can't afford to have that data down for a select part of your backup environment, and then backing up the rest of it directly to Cloudian or using your existing environment. And then also taking Cloudian to that next step and using that to kick data out to the cloud for you and truly archive your data that you're not going to be touching anymore for long-term retention. And I wanted to show one more example here, and so this is actually a Twin Cities, large Twin Cities enterprise, and this is how they're using Elastic in their environment. Elastic has a traditional DAS type architecture where you've got hot, warm, cold buckets as direct attached storage to each node, and what you get there is inflexible environments. This should look similar to a Splunk environment or a Vertica environment with their kind of traditional architecture. And what you get out of this, the first thing you can do is, instead of using direct attached disk, a lot of these architectures are shifting to using what I would call a virtualization model. So let's split up the compute and the storage portion so that you can scale each of those independently. This is the model that we really, the whole industry embraced with virtualization. Quit making servers be an independent piece of your environment. Let it all grow and scale as you need. And especially in Elastic here, what the customer has done is they use NFS for their primary storage for the actual. So what they do here is they're using this for their security logs. So they have a time series indexes coming in. So as data ages off and they're not analyzing it anymore, they keep it for retention, and so they automatically then kick it to Cloudian for that long-term retention. So what lands on the FlashBlade is every quarter basically the FlashBlade fills up and then drains off about a third of it as it archives that. So that's done two things. One, obviously that's made that super easy for them to scale their environment, and it's made their environment very hands-off. It's also allowing them to offer Elastic more as a service now. And so instead of having to have one colossal and Elastic environment, they can start splitting it off and having separate indexers for specific specific workloads. So, maybe your security team doesn't want to share with your marketing team. You can provide a service to your company, and this works with, like I was saying before, Splunk or Vertica or any of those other kind of traditionally direct attached models that those companies have realized that you just cannot scale to an enterprise scale with those models. Dave, do you want to add anything?
Sorry, struggling to get off of mute there. No, I think you described it perfectly, and really what this is doing is providing a high-speed, highly available, and cost-effective solution for, it could be Elastic, it could be Splunk, there could be a lot of different workloads where, we're complementary to each other, because once again, the whole key here is to have a tiered environment where, you're not going to put yourself in a position where if you have to pull back a piece of data or restore something, you're not going to meet your SLA. So this allows you to present out a kind of a best of both worlds deployment that allows you to have a rather fast tier, or I would say a very fast tier storage, and then a deep archive, all on-prem, right? So once again, especially when you talk about security logs, things like that, a lot of times people or companies are very uncomfortable storing that in public cloud because it's very sensitive data and very expensive if there's a security breach, right? I like to say, you can go to public cloud and you can trust whatever you put in there, but at the end of the day, if you're a company, you're not hiring those people, right? This gives you the ability to have a little more control because you have your own, basically you have your own on-prem solution, and you have people that you hire, manage, and trust to execute on it. So,
first question we have is, how much data should be kept on high-speed storage, and how much should be archived?
It really comes down to how you want to use the data. So, so you're not wasting a lot of money putting everything on high-performance storage if your data science group only wants to look at the last 90 days, if they decided that's what's most relevant to them. So it really comes down to, working with your application owner, working with the data science group, and figuring out what they really need so that you can help provide an environment that will scale the way they want, but also you're not, wasting a lot of money on high performance that you don't necessarily need.
Yeah, I would agree that it really comes down onto a customer by customer basis, where what are you comfortable with, right? There's some customers where, to be honest, they don't need Cloudian because they say we keep our backups for 30 days and then we delete them on the 31st day. I have no need for you, and okay, fine, that's a reasonable request. There's other customers that say I need to be able to have really fast restores for whatever my application is for up to 90 days because they search data on a quarterly basis. After that, there's a high likelihood we won't touch it again for 3 years. Typically, that's where you work with the customer and go, okay, what does your 3-year footprint look like? What does your 90-day footprint look like? And based on that, that's where we kind of come up with configurations that we believe would best suit the customer, on a blended, high-performance, deep archive basis.
Okay, great. Thanks for that. I'm going to roll into our next question. How is Cloudian different than other on-prem object stores?
Well, I would say that the key differentiators, if you look at other on-prem object stores, and I'm talking about the deep archive players, is number one, the S3 compliance, as we talked about, that new object lock feature. As of, the most recent time I heard, we are the only ones today supporting that. Will other on-prem vendors support that? Sure, but it's going to take some time to implement, test out that API, make sure it works. So I would say the 3 key differentiators, if you walk away from this webinar with, how are we different? Number one, by far, our S3 compliance. We do it better than anybody else. Number 2 is the ease of use, right? You can start off with 3 appliances. From there, you could add 1 appliance, 5 appliances, as many as you like, as simple as plugging it in, configuring the IP addresses, turning it on, and walking away. In the background, the data automatically rebalances across the nodes, so you're not manually manipulating data. There's not a lot of moving parts and pieces, right? So there's no admin nodes, metadata controller nodes. You can connect to any node, and they're all peers to each other, which makes it not only a simple solution from a hardware perspective, but also easier to manage. And then lastly, it'd be, our ability to start as small as 96 terabytes and then scale, as I mentioned, to petabytes or exabytes. So there's other providers out there that if you look at it, you might start off with 500 terabytes or a petabyte in size. You want to go to a second DC, you're now scaling in 1 petabyte chunks. We don't require any rules like that where, you have to scale in the same denominations. The amount of capacity in your data centers don't have to be the same. So, once again, third biggie would be that we start smaller than anybody else and we could scale to, to exabytes.
Thank you, David. I'm going to move into our next question. When is scaling up an advantage and scaling out an advantage?
I would say that, the main difference between scaling out and scaling up, right, is that go ahead, Rob. You want to take this?
Yeah. So I would say, there's a reason that both Cloudian and Pure have scale-out solutions instead of scale-up solutions, and it really comes down to what the data is being used for. When you get into these kind of analytics plays or even deep archive plays, you're not adding as much compute in a deep archive play per kind of brick as you are in a performance play. But what it allows you to do is really push the data that you're putting into the environment. The problem with a scale-up solution is that it's a huge jump to the next biggest appliance or the next biggest controller. Where if you can scale your storage and the compute linearly to meet your environment's needs, you can really take advantage of some growth over time and not having to really build out your environment all at once, planning for the next 5 or 6 years that we all know we can't really plan for.
Thank you, Rob. I'll move into our last question. What are some of the typical industries that Cloudian is deployed in?
Cloudian is in a variety of them, right? I think we showed at least some of the workflows in one of our slides. Backup is probably one of our lowest hanging fruits, but from an industry perspective, ISPs or internet service providers, they happen to love us, and those are some of the guys that get into the petabytes in size, right? Because they're basically trying to be like a mini Amazon, right? Competing with Amazon for business, providing things such as backup as a service, storage as a service, and while we didn't get too deep into it, in addition to being able to scale and ease of use, Cloudian has a lot of functionality that's required in the ISP space, things such as multi-tenancy, quality of service, right? So you could throttle users so that if you have multiple companies, groups, or users, one user can't take all the available throughput, from a specific appliance, as well as things built in like billing, so you could generate billing at the end of the month. So that's a big one. Media and entertainment as well. We are certified with multiple media asset management companies, our asset managers. And the other thing that we didn't really talk about is the ability to do metadata tagging on objects at ingest. So there are a lot of tools specific, across a wide range of industries, but especially in the media and entertainment, whereas they ingest, whether it's images or video, they want to tag it, so that they can go back later on and search for a specific actor possibly that they ingested video on, or some specific pictures that are, relative to New York City or something like that. So our ability to support custom metadata tagging as well as just integration in with media asset management software are another industry. And then, there's a small handful of other ones, right, such as financial services and healthcare as well.
Thank you for that, David. And again, please be sure to check out our attachments below for more information. Thank you so much, everyone, for joining us. Have a great rest of your day.